Hello everybody, this is Dynamation4, and we are here to do a little bit with Redstone in the new update. Now something I've learned is pistons love to use teamwork, and they hate when you put signs on them. So we are here to do a little bit with more advanced redstone techniques. So we're going to start off with a little bit of basic stuff. First thing you should definitely know is piston signal blocking. Blocks the signal. Another way to do this is using a torch. Invert the signal, then power the inverted signal, makes it act like an AND gate. This would be the blocked piston. So if it's not powered, the signal goes straight through. Basically an AND gate. Redstone doesn't power through the corners. Pretty simple. Power with a repeater. Redstone can get it if it's next to the block or repeaters, even if it's not facing it. So all the lamps turn on. Power with redstone. Repeaters can get it from the blocks, but redstone can't, even if it's facing it directly. And dust redstone acts like 4 ways. So now you got an OR gate. Pretty simple. That light is A or B. Just comes together and comes out, so if either one of them's on. Now a common misconception is that there is an AND gate. There is actually no such thing as an AND gate. What it is it's a not A, or not B gate. 3 nots there. Of course, that being a not. So if both of these are powered, then both of these signals get depowered. And only if both these signals are depowered does this turn on. Which makes this, when both of them are on, signal is on. So acts like an AND gate would, even though it is a not, or not gate. 3 nots there. Another important thing is this little thing right here, strength checker. So redstone is emitted by emitters like levers, buttons, but not by like heavy pressure plates and stuff like that. It is always emitted in signals of 15. So once it gets to 15, it dies and it does not emit to the next one. So what you can do is say, if this one's on, torch turns off. If this one's off, it stays off. So both of these will be off, and the torch can turn on. If it gets to here, then this turns on, and the torch turns off. What this means is that the redstone torch is the greater than or equal to, and the redstone repeater is the less than. So if it's greater than or equal to blue, but less than red, then you can get this, which will give you blue or yellow for this. This one, greater than or equal to yellow, but less than red, which is just equal to yellow. So if we pull red, nothing happens. If we pull yellow, they both turn on. If we pull blue, that one turns on. It always takes the highest signal, so if we pull blue, that does not turn off. If blue was over here, then it would. So we pull red, they're both out. So now we can get into what we're really here to talk about, programming with redstone. Yeah, it seems crazy. What it is basically, the idea is, you start the program by sending a signal. The signal continues down the line, proceeding through functions, doing anything you want to do with it, and the location in the program is running is where the signal in the main line is at. So how you can use this is, here's an if-else if using a piston. When this gets powered, signal will come through. If this, signal will go straight, and this part of the program will activate. Else, it'll turn, and it'll go this way. So else, or if. If you don't want to use pistons, you can do it this way with AND gates. A little bit more complicated, uses quite a bit of torches. Basically, this one goes up to this top line, comes around, powers these. This gets inverted here, not inverted here. Gets you the same thing. There's your else. There's your if. Another thing you can do with the booleans or true-false operations like you did with if is this while loop. Pretty complicated. Give you a second to look at it. You got a command block, 3 comparators there, 2 of them off the command block, 1 of them off this central block right here. You got a redstone repeater going away from that and 1 into the side. Signal comes back around into the block next to the command block. Back over by the lower gold block is where we're going to start. You got a torch off that, powered another block which is also being powered by the comparator, which goes down to the redstone lamp in the corner. Then right here you just got a little monostable. So what this is, it's a while loop. So in here there's a command, and most commands now do have some kind of output. So as long as this outputs a signal, so if it tests for it, as long as this is true, so while this is true, this loop will continuously run. Every time it runs, it'll check again, and if it's true that time, the signal will send through, the program can continue down this path. If this is not true when it starts, what's important is that this still turns on. So right now it tests that my score of test is 0 exactly. And we're going to list my scores, and my test score is in fact 0. So what we'll see is this loop starts to run. You can set this delay to whatever you want, but there should be a repeater here, and there has to be one here. So you need at least 3 ticks there. You could modify this a little bit, make it less, but yeah. Now you'll note that if I change my test value to 1, turns off, that lamp flashed on. Now that my test value is 1, the loop won't run, the lamp will just go on straight, as if it just powered straight through. If you put the signal here, you get a do while loop, which runs this once before it makes its first check. And that's just pretty simple. You power this also, power that also. So this ran, then it said, hey wait, you shouldn't be doing this. Now something else you can do that you can't really do in many programming languages is a wait for. Or you can, I guess. What this is you send it a signal, it'll hold the signal here until this block gets a signal. And this is a wait for using pistons. You can do non-pistons, which I'll show you in a second. What happens is the signal comes through, hits the repeater, then comes back around this way. Why is this? And gets locked. Both of these get locked. This gets locked on, this gets locked off. So it's not outputting, but this is. This gets constant stream so that these stay locked until you block the signal and they get unlocked. You can also get the status here by pulling off this way. I'll show you why you want to do that in a little bit. So let's just run this. They lock. There you go. Now you can use a little AND gate and make it without pistons. Just 2 torches, another torch, make sure the dust is on top. Now what you want to use this for is something like this. Here we got a firework launcher, and we got an incomplete line here. So you run this program, you'll see this lamp turns on. So this is the function that is being run right now. This is focus right now. Once the function returns, and this would be a returning function when you use this. Once the function returns, the program will continue. So it will return by me completing the circuit. Continues, it launches the firework. This is an example of a non-returning function, where it doesn't matter what happens over here. You can break the signal all you want, but the function will just continue on regardless. This function will run, do whatever it wants to do. This doesn't need anything from it. It may need it later in the program, but in which case there needs to be wait for there. So now I combine some of these things. I made this nifty little program right here. It's fairly simple. You can see what's going on. You got a wait for, you got a while loop, you got another wait for. So I actually wrote a little bit of Java code for this, some pseudocode in Java. So you got your main thing, the prompt for input, which is a function for int x equals 10, x is greater than 10, x minus minus. Launch rocket, which is another function. Then it prompts for input again, then prints end. So let's see that happen. So right over here, this would be prompt for input. And the light is on, push the button. That's the prompt. Then counts down 10 times. 1, 2, 3, 4, 5. I can't count this. That's 10. And it prompts for input again. And it says end. Pretty nifty. And it's pretty easy to see what's going on. You got your command block here that sets what would be x to 10. And this is what calls the function just using a little bit of wireless. It's a receiver over there. This subtracts every time. And this tests while it's at least 1. Because there's no greater than 0, so you need to say it's greater than or equal to 1. Then over here is the next wait for. And the pink line powers this light, which says that it's stopped at one of these points. The yellow line gets from the button, which says, okay, continue on from these points. The blue line is the main line of the program. So if we come back here and watch it, see, right here, power, it moves on down this line. Now you're here and it's cycling. Then it goes back through. Now it's here. Power this, and it finishes. So that was like the line of the program right there in dark blue, with all the functions and all the other colors. But also with while loops that I forgot to mention earlier, is you can do them without command blocks. If you don't have command blocks during survival, or you just want a redstone signal to change it, you can do it with pistons, or you can do it without pistons. With pistons is a little bit more compact and allows for different angles. This is a little bit quieter. So right now, it's not true. So the signal just powers straight through. You make it true. Begin to cycle. And then it'll go straight through. And you can see that right here you do have one of those wait fors with a comparator for the timer, a double inverter. This interrupts the signal. When this is powered, this is going to stay depowered. And this changes the wait for. So if this is already off, it's just going to power right. Yeah, because there's a torch right here. If this is off, this is going to stay powered, and it's never going to lock these, and it's just going to go straight through. So over here, I got some use for the 1.7 functions. If you notice, scoreboard, objectives, add. Normally you had dummy health, player kills, deaths, but now you got a whole bunch. Oh wait, you need a name. It. You got a whole bunch. All those things you can do with objectives, you can now do here. See, achievement, kill wither, anything, how many times you've done it, would all be stored in these values. So what I did is I made an objective called coal, which is the amount of coal blocks you mine. So I'm going to switch to game mode 0. I made this little thing here. It's an achievement system. See the while loops? It waits until I get at least more than 9. And then it waits till I get more than 63. It should be until I get 10, until I get 64. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have gotten the coal miner achievement. No, I didn't even have to pick them up. Just the fact of me mining the block made it. So I'm going to do a bit more mining here, and we can see what happens. Okay, so you can see I've gotten 60 coal. And you should also note that now the signal is here. So you could use this if you wanted to get achievements in a row and not let people jump around when they got their achievements. So you'd have to get this one before you get that one. They don't necessarily have to be both coal. So 4 more, and I'll have a stack. That'll be 64. You'll see something happen. You've gotten the coal mountain achievement, 1 diamond reward. Yay! Okay, so put this back, which you'll see will run the program again, and also sets it to 0 here. And now we can go over here to something called a switch case. If you don't know much programming, a switch case is you get a value. In this case, it would be a color, blue, green, yellow, or red. And when the program gets to it, by pushing this button, it'll continue on a certain path. So we're going to push this to start the program. So you see, this is a wait for, and it's all waiting. And let's push green. Green light goes on. Now if we push yellow, nothing happens. This is because the wait for turned off. When you push it, they all come down here, and they can all deactivate the wait for, which deactivates these. Then you have the signal checkers here, checking if it stops right here, right here, right here, or right here. That's why these placements are important. It's 4 blocks, red, 2 yellow, 2 green, 2 blue. And then these signals just get traveled up. And long story short, if these both turn off, this turns on, proceeds down. And it also shows you how you can use one line of redstone for multiple uses. How would you say that? You can use one line of redstone for multiple signals. Like this would be a red signal, this would be a blue signal. You can just get them however you want. And theoretically you can stretch this on forever, but this would need to be removed because not all signals could make it there. Now this is kind of bulky, but it doesn't use pistons, which is nice. But if you want it compactor, you can really tighten it up and use pistons here. So you got here, all these go out at once when it hits the program. So you kind of hear it if it was close by. And then hit one of the buttons, goes through, all the pistons retract. You see the wait for here doesn't go anywhere. You'll note that, because the signal will be going down one of these instead. So this actually isn't necessary. And what happens here is you have the dust, which transmits through this block, and the repeater gets it from the block, then transmits this way through to the lamp. It also goes underneath, comes around, hits the piston to deactivate these, and all the pistons will retract. So pretty simple when you think about it, but you can combine them together, make really long complicated programs. This one's not that complicated, but not doing it this way would be pretty challenging, I think. And it would take up a lot more space. So yeah, some fairly advanced redstone concepts. One line for multiple signals, while loops, do while loops, if else, wait fors. Yep, that's probably going to be about it for this. I am using all this stuff in redstone circuitry right now. I am making a device type thing, a map I guess I should say, and I'll give you a clue. It's in Minecraft. Yeah, so I'm using this. Really helpful. Makes everything make a lot more sense. You could just follow the line, see what's going on, see where it's breaking, like you would with programming. And yeah, that's about it. Thanks for watching.